Hello and welcome to our segment related to one of the most exciting things that are a part of the internet as we know it, root leaks. At least this is the case of Mingwei Zhang, Senior Systems Engineer on the Cloudflare Radar team based in San Francisco, and Vasilis Giotsas, a research engineer based in London. They both are here with me. Hello, Vasilis. Hello, Mingwei.
Hello.
Hello.
And you both wrote a blog post also with Celso all about root leaks. And in this segment, we'll try to understand a bit why root leaks are relevant on the internet. I'm João Tomé, storyteller and a root leak non-expert at your service based in Lisbon, Portugal. And Lisbon, Portugal continues to be under heavy rain and floods. So hopefully that will be sorted out next few days. So let's dig right into root leaks, starting in terms of what are root leaks and why are they relevant on the internet? Who wants to jump the gun here in terms of explaining the non-expert what are root leaks?
Maybe I can start.
Sure.
Root leaks are the propagation of a routing path beyond its intended scope. And what does it mean is that in the internet, paths have some policies attached on them because autonomous system, internet service providers don't want just the shortest path, want paths that are efficient, paths that are cost effective. So they attach policies on the routing through the de facto protocol BGP. Now, quite often due to a misconfiguration or sometimes intentionally, the path may not actually be what was intended by the policy, but it may propagate to autonomous systems that are not initially intended to. And that can cause all sorts of issues, from performance degradation to unavailability or to some security risks, such as man-in-the-middle attacks.
So yeah, it's all about related to internet protocols and how the internet works in essence, right? And BGP, the Border Gateway Protocol, is on the basis of how the internet works, and sometimes something that isn't supposed to happen happens, and it's called root leaks in a sense, right? The name already explains what it is in terms of there's a problem with the route that a packet or the internet in general, as we want to call it, should be to the destination where we want to go. And there was a problem with that route. The route was not the preferable route that should be intended from the user in a sense, right?
Exactly. It's not a preferable route that should be intended not just for the end user, but also for the intermediate networks that propagate this route. You should remember that the internet is not a monolithic network. It's a collection of individual networks, which are called autonomous systems. And each one of these networks tries to author a routing policy based on its own interests. And they have to collaborate together in order to achieve end-to-end reachability. But sometimes errors happens, or sometimes maybe some of these networks are not benevolent, so we end up with a situation where the route is not legitimate, or where the route is following a path that is non-canonical.
Exactly, and then that when the problem happens. Do you remember, Vasilis or even Mingwei, problems related to root leaks in the past few years that were more known, more relevant, that created more problems in terms of internet users in a specific region, for example? We have like examples to state here.
Yeah, I can try one. So I think in the blog post we already also mentioned that there's the Nigerian ISP. I think in the last paragraph here, right? This is particularly impactful because it's relevant to Google's prefixes, and so what happened is that the small ISP, it's relatively on the edge of the internet, was misconfigured its route and then propagate a completely wrong routing information. So thinking of this like a yellow page, like where you basically spread out your information about how to reach Google. And if you feed others or provide wrong information about that, and other networks believed it, then you might cause issues. And in this particular case, the issue is that everybody believes that through a small ISP, you can get a better connection or a preferred connection to Google instead of paying other networks for transit, something like that. And then the internet was basically flooding the small ISP with the traffic toward Google instead of sending it over to its regular next hubs or regular transit providers. And then as a result, this small ISP was basically overwhelmed, and then the Google was cut off for a few, I forgot the exact length, minutes or hours, just because of the everybody is reaching Google through a different and
74 minutes outage. So that's a relevant outage there for sure. This is the blog post that Tom Paseka wrote back in 2018.
Yes, and this is so as we can see here, that regardless of the size of the network, because of the kind of a collaborative nature of routing, and as Vasilis mentioned, there's kind of a federation of networks where basically we are putting in trust, in somewhat relative trust to each other about they're spreading the right information. The size doesn't really matter in terms of how we keep the network secure or performant. It's so we need to be careful about what to accept and validate the information will be as a network operators, and in order for us to prevent such events from happening again in the future.
Makes sense, yeah. I was showing here in this case the specific routes that Google was using in terms of the problem that happened in Nigeria with that ISP that you're mentioning. This shows like
this is a typical
this
is a typical route that the network would take from a regular perspective. And then in the middle, we're looking at is a tier 1 AS, which is the big one that is able to handle the amount of traffic that are sending to Google. And then in the routing event, what we're seeing is that the amount of traffic that's supposed to send to tier 1 was actually sent to a small network, which was basically overflooding the network with the request. And that's causing the outage.
Exactly. For me, it's really interesting just to see how the internet is a network of networks. And this is all related to that, because networks need to be communicating with the right networks when they want to reach some place, in this case, some website, some domain. And it's this communication, these routes that sometimes have problems. But it reminds us really in a very clear way that the internet is really a network of networks. They all have to communicate with different networks to reach the intended destination, in a sense. So it's a good reminder, I think, of that. We announced in this blog post, in a sense, we're announcing how we detect root leaks, but also we now have a new Cloudflare Radar root leak service that people can use to check root leaks. Usually, the users of these tools are engineers, people that work in this area, right? But if you're curious and want to learn more about the internet, you can also check Radar as it is, in a sense, right?
Right.
Mingwei, go ahead, sorry.
Let me know that from the previous example that Mingwei described, the error happened in a very remote AS to Google, but it still affected Google and its users severely. So Google engineers at that instance could not detect that something happened up to the point they started receiving reports that reachability has been affected. So it's important to have a tool to detect these things in a timely manner before they start severely impacting the connectivity and the reachability, in order to resolve them also in a timely manner.
Exactly. It's all about solving the problem, because it's not sometimes clear that the problem is there. This is a way also of stating that the problem is there, right?
Exactly. And you know, this tool that Mingwei will present is doing exactly that. It provides these timely detection capabilities that until today probably were missing from most organizations.
There's different types of root leaks, right? Also, we can discuss a little bit of this. It's stated here in the blog post.
Yeah, of course we can. So, and so this, before jumping to the types of root leaks, there's a kind of a topic that I want to chat about is the reason why we're not able to stop route leaks at this point. I mean, preferably we should be able to design and use a system that is preventing people from, or operators from, making mistakes and then propagate the mistakes. However, at the current stage, we are still kind of in the early stage of developing and then deploying systems that are cryptographically sign sign the routes so that people can understand, or this is a correct route instead of a misconfigurations, and people can tell the differences. But without the deployment of the system, such as ASPA and then a few other RFC proposals described in the blog, we cannot kind of effectively prevent route leaks from happening. So that task of preventing this route leak from propagating needs to be done entirely by the operators of different networks, to be able to kind of vigilantly verify routes, and then define the policies of their customers, and define policies of the neighbors, the networks that they know, so that the misconfigurations does not propagate. And so
that's work being done there for it to be better, right?
Yes. So there's work being done there. There's work that is being done to prevent it from happening, but we are still far away from securing the BGP, securing the internet routing as of today. So that's why a detection system, as Vasilis mentioned, is very important. Kind of like a situational awareness to where we want to know what's happening and we want to react, even though preferably we want to stop it. But at the moment, we can't.
Exactly. And even explaining that something happened will allow different operators, in this case, to be aware that something happened, even if it's 5 minutes. And also, possibly, hopefully, they will learn how to make it better, not to happen again, if they are more conscious that it happened and why it happened, mostly that, right?
Right. So let's talk about the types of route leaks. So this is derived from the RFC 7908, which is the document describing a well-recognized different types of route leak. So we linked that in the blog post, and then you can read more from that document. And here in the blog, we try to illustrate that different types in graphs. And the key point, or the key kind of takeaway point, is that the relationships are described as provider, customer, and work and peer-to-peer relationships. And the route leaks are usually defined as a wrong turn in the routes. So in this type 1 example, where a provider propagates a leak or information or routes to a customer, and then customer take that routes and then send it over to another provider, this creates a leak, or in other words, called a valley route. This is specifically impactful because the other provider, who usually get charging the customer for any traffic that the customer uses through this provider, will prefer customer routes. In this case, AS6 or Network 6 we prefer the customer routes instead of, say, a direct peering with AS4. In this case, then we're basically flooding the AS5, the customer, with traffic that are not intended for it to carry, which is similar to what happens in the Nigerian ISP case.
And it's really impactful, right? This one.
Yeah, this is impactful, and this is a relatively kind of a high visibility event, and that could potentially be a global event if the filtering mechanism was not in place.
Global in the sense that it has an impact in terms of internet access globally, right?
Correct. Just similar to what happened on the Google side, where if exactly. The traffic route is happened to about Google, then it could potentially propagate globally and then cause Google's outage or any network's outage for an extended period of time.
And about other types, what should we mention?
And there are other types that are not, or how to say, potentially benign cases, like in this case where we have multiple lateral peers that are sending traffic to each other consequently. This is not a usual case, and we often see that, however, in the real world. So in this particular case, if you see like three really large networks that usually peer each other and then see this pattern, is sometimes indicating a problem. Right, but it's not as important as type 1. And there are also other types like type 3 and 4, which is where you, after propagating to a customer and then you propagate to another peer, or you receive the routes from one peer and then repropagate to a provider. This is by definition a route leak. We are monitoring all these 4 types of route leaks because they're basically, we're looking at AS paths. But in terms of impact or the impact to the routing, we're still focusing on type 1 as our system design perspective.
Exactly, makes sense. Just a question here. So the provider, the one that leaks, that does it, where the problem happens, is the one that is controlling a specific ASN. Usually they're the internet service operators, ISPs, that are creating, in the sense, the route leaks, right?
Yes.
Okay.
And in all those cases where we see 3 ASs are involved, and that's
right.
How we can understand is that the middle one is usually the leaker, in a sense, where it takes the routes learned from one provider or one neighbor and then propagate to another neighbor, which are not intended to be, or a misconfiguration similar like that. So if you see in our system, we also show 3 ASs involved, and then the actual leaking one is the middle one in those cases.
Okay, makes sense. You were saying something, Vasilis?
Yeah, I would like to briefly explain this provider, customer, and peer relationship. So as we said, the internet is composed by thousands of networks. Some of them are very big. They may have a global footprint. Some of them are very small. They are local or regional. So the small ones need to access the entire internet, right? And how they do it, they find a larger network and they ask to get access to their own network. And in exchange, they pay them for their privilege, right? So this is a customer to provider relationship. A smaller network gets access to the backbone of a larger network. Now, 2 networks may decide that it's for both of them beneficial to access each other's networks for free. And this is what we call a peering relationship, right? So in the peering relationship, there is no exchange of money, but there's exchange of traffic. And if you think of route leaks violate the economic and financial interests of an AS, because when a customer receives a route from a provider and advertises it to another provider, which is the help in turn, the type 1 that Mingwei mentioned, then it has to pay both of these providers, because it's a customer, it has the small network that needs to pay. So it pays both of them to transit traffic between each other, but it has no benefit, right? So we can think of fraud leak also as a violation of financial interests, right? Which means that the leaker, the AS that has the misconfiguration, also needs to be aware of the leak because it may impact its finances, unless it's intentional, right?
Mhm. Exactly. Sometimes it's intentional. Sometimes there's intention there to cause harm, right?
Exactly. Cause harm to attract traffic to its own network for purposes of intercepting it and so on.
Yeah. And one of the things that makes raw leak detection specifically hard is that, as you mentioned, it's intention. There's sometimes we cannot learn about intentions between networks where their business relationships are, we have to infer, and there's no way, or there's no good way, centralized way to kind of learn the ground truths for this. So we, in order for us to basically monitor the global network internet, we have to kind of infer, and that becomes usually a problem. And then Vasilis has published several papers, academia papers on this specific topic, and they're really good. And then we think we expanded on that, and then to base our system on the existing kind of research papers, so that we can kind of be more accurate in terms of inferring the relationships.
Exactly. Mingwei, can you guide us through a little bit of what we have on radar in terms of root leaks? And also, if you can explain a bit of how we built this here and use our network, our global network, to help there.
Yes, of course. All right, so at this, so I'm sharing the screen at this particular page. We're looking at the radar, .cloudflare.com, which is the main page for radar. We are building everything, building the center hub of everything that we see on radar. So that includes the BGP information that we collect or see, and then also raw leaks. And so if you go to the security and then attack page, so without any specific filters to ASN, we're looking at a global view of the internet. And then toward the bottom of the page, we now added the global routing raw leaks table, which are representing everything that we see in terms of raw leaks, regardless of the network. So you can see a lot of ASs involved, and they usually happen not that frequently. We are being very careful on kind of removing the false positives, and we're trying our best to be accurate on the detection results. But of course, if you see anything that is particularly jumping out or not potentially incorrect, let us know. In this particular case, we can take one example, like look at a small ISP here. I think this is a small ISP. Maybe. Sorry, I'm really bad at geography. All right. So this is jumping out because it's on the front page, and then so this is the one specific AS or network page for this particular AS. If you scroll down to that part to the bottom, we can see that there are few raw leaks that are kind of generated or initiated by this particular AS. So if we look at the table specifically, we can see the 3 ASs involved, the front, by, and to. So what we can understand, how we can interpret this is front is where the routes are coming from. So, and then by is the leaking AS or the leaker AS. It basically tells us that this AS learns the route from its provider 3356, level 3, or I think it's Lumen now, and then propagate that to the next to is the other provider, which is the other one. So that's 2 part. And we can see that the time, the starting and ending time.
But it wasn't that too. It wasn't the ASN it was supposed to propagate, right? It was the leak. Right.
This particular is the leak, right? So what we can see here, we can know for sure that this is another provider of this AS. So it's not supposed to go into this provider.
Oh, exactly.
But it happened, and in this case, it happened actually yesterday, and then it lasted about 30 minutes ish, and then later on in the paper, we can see that it involves 3 prefixes, about 2 origin networks of these 3 prefixes. And then from globally, we observed about 700 messages, PGP messages about this particular leak, and then has been observed by 230 vantage point from our system. So in total, we have
the BGP message and vantage points in terms of what it means.
Right. So when the deep BGP message we're looking at here is basically the messages where the leaking happens, where basically the leaker is announcing that the paths you can reach, you can basically the propagated the paths of the routes, right? So we can consider the BGP messages as the individual message for the propagated routes, right? Right. So that's about 700 messages or 700 individual messages about this route, and then observed by 230 vantage points on the internet. And then for now, we're
there. And in terms of meaning,
the vantage point is the route collectors. You can consider that as those watchtowers or eyeballs or routers, systems that are watching the internet routing. Yeah, and then basically allow us to be able to tap into their watchtower and then to look at what routes are being propagated and received. Right.
When the vantage points are higher, the certainty is higher because more vantage points were seeing the route, and the route was not the supposed one; it was a leak, right?
Correct. In this case, the higher, more vantage points, the more global reach it has. So in another example, we can see that there were very limited visibility events. There are 5 messages and then lasted about 10 minutes and only be seen by 3 vantage points, which is about maybe 0.5% of all the vantage points we have. So that's a limited events and only kind of it didn't have a global impact in this case.
Makes sense. Any more that we can explain here?
Right. Not at this part. I think that's so we're still expanding our capability of the radar raw link page here. For example, bringing more information about ASs so that we don't have to look at just numbers. We can look at more like the names and then the other.
That's amazing. That's really helpful. Even and I was checking. You do that when you pass over the mouse. You could see the names of that ASNs. And when we're dealing with ISPs, big ISPs, sometimes you don't know what are the names. Of course, it's difficult to memorize. It's just having that there, it's really helpful to get a sense of, is it Verizon? Is it sometimes in the bigger ones? Which one is it? Is it Vodafone?
Right. So for curious readers are like more interested in radar, so we recently introduced an information block here that tells us more about the information about any particular ASs that we're looking at. And we're trying to bring in more such information to the route link table as well for users to be able to more easily observe and digest the information. And then in this particular case, I want to mention that this is a very large network. And what you expect from this very large network is that there will be a lot of route links involved with this network, but it's usually at the from side. It basically means that there are leakers that take routes from this very large network, which is usually the provider of the leaker, and then propagate that to another provider. So you see a lot of route links by large networks, but that's not there to blame. We're not trying to blame anyone.
It's the ASN that is on the buy that is to blame, right?
Yeah, the buy is the potentially to blame, but we're still trying to make sure that they to increase the accuracy there.
Exactly.
Right. Yeah, but so if you see a lot of networks, raw links from a particular network, and you see that from as the from side of the raw links, that usually means this is the provider, the large provider that providing a lot of network transit to potential leakers at those points.
Makes sense. Was a good explanation. Anything we should mention in terms of just under how we did this in terms of data and how we are improving?
Yeah, of course. So before we jump into that, there's also the developers right now is so big. We already opened up the APIs for that for the developers. So everything that you can see from the radar page, you can create a account with Cloudflare and then get the information from the API now. And they are I believe they are open to to all developers without any charge. And then you can build your own systems with that. You can periodically query that and then it allows you to filter by, for example, leak ASNs or by ASNs involved. For example, in that previous case, we have 174 involved in many cases. You can also search for that. And then there will be some more useful information like the AS names, and then a little bit more details about the leaks there as well. And we're trying to bring in more information to this API page as we go, so that the developers can build more powerful systems with our API as well.
Exactly. They can use our information and build their own systems in a sense, right?
Right.
Sharing the information. Anything we should mention to wrap things up, even in terms of next steps and make it better?
Right. So as we go in the blog post, we talked about how we built it. I will skip most of the description there, but I want to mention a few things. Is that we basically break down the system into 3 components, and then we have this one, the raw data collection component, which takes in the information from different vantage points and then turn it into a stream of BGP messages or routes in our discussion. And then we have a system that takes and examines each individual routes to validate and then to detect leaks and based on individual routes. And then we're using multiple information sources from CADA, UCSD, and from IHR, and from our own homebrewed AS relationships data, and then as well as some public data as well. So we're combining different sources to make sure to try to reduce the false positives, and then make sure that our alerts are accurate and then actionable in the cases. And then lastly, we have a system that are trying to present the information about alerts. We have developed the API, we have the UI on Radar, and we're as the next steps, we're trying to improve the system so that we can also be more useful to operators. One of the such features that are coming up is alerts, so people can subscribe to a like a certain ASS alerts, so that every time when a new event's coming up with the certain ASs of your interest, you can get alerts either via email or like a chat notifications, things like that. We already have an internal the chat notifications that is implemented, that we are trying to build more capable, say, chat bots, and then email notifications with our system, and we can open up to everyone when it's ready. And then other things that are coming up are relevant to BGP, but are more on the security side of things. Vasilis has mentioned that there are cases where we don't particularly confident in their benign behaviors or their mistakes. There sometimes are actually intentional route leaks or even the hijacks. So we are currently in the process of building the hijack detection as well, so we can bring in the raw leaks and then detection and the BGP hijack detection together into the same place. So if you're interested in kind of more discussions, we have a Radar Discord room as well. So we can you can join the Discord and then talk with us directly. I will be on there. I believe Vasilis and João will also be on there. So we'll have.
I'm there. Actually, it's on the Cloudflare developer Discord server. So you must search for Cloudflare developers It's related to Cloudflare developers.
I already logged in. But
Yeah, you can join and talk to us. Before we go, just one thing, Vasilis, you've been at Cloudflare for a while. In terms of root leaks, what evolution have you seen? In the past few years in this area?
Cloudflare had suffered from a very serious route leak in 2019, summer 2019, which alerted not just us, but the whole internet about how severe route leaks can be. And since then, detecting route leaks and finding ways to further prevent them has been one of our priorities. As Mingwei mentioned, one of the primary things that we tried is to accurately infer how normally the paths should look like based on the expected AES relationships. But that's not easy. So part of the innovation here is the combination of different relationship data sets. And the other thing that makes our current system very unique is its efficiency, how fast it can collect this data and present them. So you can imagine that with tens of thousands of networks in the internet and many millions of BGP messages constantly, being exchanged, the amount of data is massive, right? And while trying to detect in a timely manner route leaks, you often hit this problem. And a final thing that makes this work very unique is the way route leaks are summarized. So again, in the past, we may have the detection capability, but these incidents happen all the time. You can imagine how big is the internet and how easy a misconfiguration is to happen. So we have messages being exchanged constantly. If we don't have the right way of presenting them, then someone is overwhelmed with alerts. So we were trying to find the right representation. And I think now we've reached a point where all of these three things, the accuracy, the efficiency, and the representation have, came together this really nice tool.
Exactly. For us to show in this manner, in a public forum, for, as you said before, for others in the industry can benefit from that information. This was really clear. I learned a lot about root leak. You had something to say? Sorry, Vasilis.
I said it's good for the whole internet, right? Better paths, good for users, good for operators. It's a win-win situation.
Exactly. And I really think it's fascinating how putting the information out there helps build a better internet, in the sense that at least helps the internet be healthier and better, which goes back to our mission. And it's interesting that it's just information put in a public manner, but that information can have a real world impact in ASNs, in operators, in those who are dealing with the internet. So really interesting to learn about that. And that's a wrap. Thank you.